Tonight's video is on the causes of wind and local winds. We're going to build on the lab we did in class today and see what factors cause wind to blow, how we measure it, and look at some local winds that blow over a small scale. So what causes wind? Well, first off, wind is the movement of air along Earth's surface, so side to side along the surface of the Earth. And wind blows from areas of high pressure to areas of low pressure, right? We know that pressure wants to balance. We saw that in our air pressure demonstrations, and so wind is just air moving to balance that pressure. So we can say for our notes that wind is air moving along the surface, and wind blows from high to low pressure to balance the pressure difference. All right, and so now that, of course, causes us to ask the question, why is there a pressure difference? All right, and again, we're going side to side, not up and down. So there's a pressure difference if we go up in altitude, but winds don't blow up and down, they blow side to side. So why would there be a side to side difference in pressure? And it has to do with temperature. All right, same main idea. We're still talking about causes of wind. And most differences in air pressure are caused by the unequal heating of the Earth. So air pressure differences caused by unequal heating of the Earth. And I'm going to put that in italics on mine. You might want to underline it. I'm going to underline it instead. This is a key phrase. It's really important. All right, unequal heating of the Earth. That means parts of the Earth get more heat than others. Right, and so parts of the Earth get more heat than others from the sun, and the reason is that areas get different sunlight or different amounts of sunlight because the Earth is curved. All right, as you can see over here, the Earth is a round ball, and so when you're right at the equator, the sun's rays come straight in overhead, so you get really intense, very bright sunlight. That's why it's hot there. Up by the poles, that same amount of sunlight spreads out over a really big area. So we see that it's a lot colder there because the sunlight is less intense. And this temperature difference is going to cause an air pressure difference. We know that when the temperature goes up, the air pressure goes down. And so higher temperature areas are generally going to have a lower pressure. Colder areas are going to have higher air pressure, and the winds are going to want to balance. So how do we measure wind? All right, this is going to be our next main idea, is measuring wind. We can measure two things. First thing we're going to measure is wind speed. So we measure the speed using an instrument called an anemometer. Anemometer. Practice saying it. You have to know how to say it. It is not the anemometer. All right, and you have to know how to spell it. Okay. So for the anemometer, the cups of the anemometer catch the wind and cause the anemometer to spin. We measure how fast it spins. We know how fast the wind is blowing. This should say measuring wind, not measuring wind. All right. We can also measure the direction. So wind direction, we measure with something called a wind vane. All right, and winds are named for the direction they come from, not the direction they are blowing to. So if you have a north wind, that is blowing from the north to the south. So if you were in a sailboat and there was a north wind, you would head south because the north wind is pushing you from behind. So you've got to remember your compass, right? North, east, southwest, never eat soggy waffles or whatever, however you remember it. And whatever the name of the wind is, it's going to push you in the opposite direction. And we'll go over that a little bit in class next week. So that's what causes wind is the unequal heating of the Earth. So parts are hotter and other parts are colder. That causes a pressure difference. We can measure the speed and direction of wind. So now we'll quickly talk about some of what are called local winds. So a local wind is a wind that blows over a short distance, right? It's local. And it's caused by unequal heating over short distances. This is fairly logical. So local wind is a wind that blows over short distances caused by unequal heating over short distances. And the two kind of common local winds that we're going to talk about are called sea breezes and land breezes. So if you've ever been to the beach, you are familiar with these. So our first one is a sea breeze. Oh dear, there we go. A sea breeze occurs, the wind blows from the sea to the land. Remember, winds are named for where they come from. So a sea breeze comes from the sea. So this blows from the sea to the land during the daytime. And the reason this happens is the land heats up more during the day and the air pressure drops, right? We know from our lab that soil heats up faster than water. So the land over here gets hot, air pressure drops, and then high pressure air from the sea moves to the land, right? Because we want to balance out the pressure, The sea is cooler, water doesn't heat as quickly, so this is higher pressure air, this is lower pressure air, we've got higher pressure air is going to move over, and we get a breeze from the ocean. So if you've ever been to the ocean during the daytime, winds tend to blow from the sea to the land. And at night, we get the opposite. We get something called, a land breeze. Right? This blows from the land to the sea at night. And it's the opposite. At night, the land cools down more than the sea, so the air pressure is higher on land. Let me slide this over so you can see everything in the notes there. Air pressure is higher on land, right, and it moves to the sea to balance the pressure. So this is the total opposite of the sea breeze. At night, the land is cooler, the ocean stays about the same. Right? During the day, though, it's cooler than the land. At night, the land cools off so much that the ocean is warmer than the land is. So we have this higher pressure air on the land, and it's going to blow out to sea at night. All right, we also get local winds that happen all over the place, just from little differences in cloud cover and all sorts of other things. But these are the two kind of local winds that you'll need to know because they are very common. They happen on pretty much every coastline throughout the world. So that is the causes of winds and the local winds that you'll need to know. Please write a summary for your notes and make sure that you fill out the survey question. I only got about 50 responses from the last one, and I should see 88 responses for this one from every single one of you. So please fill out the survey, and I will see you in class on Monday.